All right, so we just talked about the even and odd identities, and I want to point out that over here on this sideboard, I've added the even and odd identities onto our list of fundamental identities. These identities you want to get to know like the back of your hand. You want to be really comfortable with all of these. Okay? All right, so our last set that we want to talk about in terms of fundamental identities, identities that you want to have memorized and be comfortable with to be able to use as tools in your toolbox, are the Pythagorean identities. Now, these identities that I'm about to tell you about are based on the Pythagorean theorem, and so when we talk about the Pythagorean theorem in terms of trigonometry, you might think about an angle in standard position, and then we have our point there and we draw our triangle. And in terms of a regular triangle in standard position, we have our angle in here of theta. We have our x, our y, and the r value on our right triangle. All right, now Pythagorean theorem says that x squared plus y squared is equal to r squared. So we're going to use that piece of information. We are also going to be using our definition of sine of theta in terms of x's, y's, and r, and sine of theta is equal to y over r, and cosine of theta is x over r. Okay, so here is our first Pythagorean identity. So we're going to start with the Pythagorean theorem, x squared plus y squared equals r squared. Okay, so that's something that we have. That's our Pythagorean theorem. It's always true for every right triangle. And what we're going to do is, for this equation, we're going to divide both sides. Oops, I forgot something up here. I forgot my square. Okay, there it is. X squared plus y squared equals r squared. We're going to divide both sides by r squared. Okay, it's not clear why we're doing that. Just hold on. We're going to get there. Here we go. So we have x squared plus y squared divided by r squared. Anything I do on the left side, I also have to do on the right side. So I have r squared divided by r squared. Cool. This right side, r squared over r squared, well, those cancel and they leave us with a 1. And over on this left side, because I have an x squared plus a y squared, I can divide the r squared into both terms. So I have x squared over r squared plus y squared over r squared. Okay? Again, it's not clear why you might want to do this, but if you agree that this is a legitimate thing to do, then keep going and hold on. Okay, so here we have x squared divided by r squared. The top and the bottom are both squared. You should convince yourself that x squared divided by r squared is the same thing as x over r, the whole thing squared. And the same over here for y squared over r squared, y over r quantity squared. Okay. And now, all that's equal to 1. Now this, written right here, x over r. Here we've got cosine of theta is x over r. X over r is exactly the same as cosine of theta, so I can write this as cosine of theta squared. Y over r, that's the same thing as sine of theta. So we have sine of theta squared equals 1. Okay, now what I've just written down here is a version of our very first Pythagorean identity. Cosine of theta squared plus sine of theta squared equals 1. Okay. Now, we're not quite done because this is not how the cool kids will write this. The cool kids will write this as cosine squared theta plus sine squared theta equals 1. Okay? So when I'm thinking about all the cool kids, what the cool kids are doing is the cool kids do not write cosine of theta with parentheses and square it, because that's a lot to write. Okay? Instead, what they do is that they put that square on the cosine function. So this would be cosine squared of theta. So anytime you ever see a trig function squared and then the theta, what that really means is take the trig function with its input, cosine of theta, and then that is squared. Most of the time when you're hanging out on the street talking to people about trig functions and writing them down, they're going to put the square right on the trig function. But you want to make sure that those two are the same. Now this is not the same as cosine of theta with a square and no parentheses, because this expression with no parentheses, this guy means cosine of, and then the theta is being squared. So you want to make sure that when you're trying to be a cool kid, that your square goes on the trig function or that you use parentheses. Okay? Okay, so back over here, our very first Pythagorean identity is cosine squared theta plus sine squared theta equals 1. Okay. I cannot emphasize enough to you how important this particular trig identity is. If I were going to get any trig identity tattooed on my arm, this would be the one. Okay? Cosine squared theta plus sine squared theta equals 1. This gets used all the time. Okay? If you learn nothing else in this class for the entire semester, learn and be able to state that cosine squared theta plus sine squared theta equals 1. Okay, so that is our first of the 3 Pythagorean identities. There are 2 others that relate some of the other trig identities, and we're going to talk about those as well. The other 2 Pythagorean identities are pretty cool. Not as cool as this guy down here. I mean, this guy is so cool that he should have green surrounding him, and red, and orange, and purple. Cosine squared theta plus sine squared theta equals 1. All right, so the other two Pythagorean identities that I want to talk about, I think of those as alternate versions of the number 1 Pythagorean identity. The number 1 Pythagorean identity being cosine squared theta plus sine squared theta equals 1. Here are the alternates. So the second one, we're going to start with the number 1 best Pythagorean identity, best trig identity in the world. Cosine squared theta plus sine squared theta equals 1. And we are going to divide by cosine squared theta. Okay? All right, so let's see what happens. We have cosine squared theta plus sine squared theta divided by cosine squared theta. And on the right side, we have 1 divided by cosine squared theta. Okay? So on this left side, I have a plus sign on the top, so I can divide the denominator into both terms. So I've got cosine squared theta divided by cosine squared theta plus sine squared theta over cosine squared theta equals 1 over cosine squared theta. Okay. Okay. So looking at this equation that I have here now, this first expression, cosine squared theta divided by itself, that gives me 1. That's the easy part, or easier part anyway. These next 2 terms over here, okay, I want to think about what is actually happening there. sine squared theta over cosine squared theta. That's the way the cool kids write your trig functions, with a square on the function. But what it really means is sine of theta squared over cosine of theta squared. And since both the top and the bottom are squared, I can rewrite this as sine of theta over cosine of theta, the whole thing being squared. Okay, so all of that in that thought bubble up here tells me that instead of writing sine squared theta over cosine squared theta, I can rewrite this as sine of theta over cosine of theta, quantity squared. And on the right side, I can do something similar. Over here, in the 1 over cosine squared theta, that's the same as 1 over cosine of theta. All of cosine of theta is squared. And by the way, that's the same as 1 over cosine of theta, the whole thing squared. You should check that if you square the top, you get 1. And if you square the bottom, you get cosine of theta, the whole thing squared. Okay. So back over here on the right-hand side, we have 1 over cosine of theta squared. All right, now I happen to be hanging out down here at the bottom of the board, and I happen to be right next to these fundamental identities. Ariana, do you see any fundamental identities here that are showing up in that equation? Why, yes, Diane, I do. I see a sine of theta over cosine theta. There it is, sine of theta over cosine theta, and that's tangent theta. So I can replace sine of theta over cosine theta with tangent of theta. So on the left side, I have 1 plus tangent of theta squared. And 1 over cosine theta, oh, that's the same as secant theta. So 1 over cosine of theta squared is the same as secant of theta squared. So this is our second Pythagorean identity. Now, we're not quite done because it's not written as the cool kids would write it. So I'm going to write it in one final form up here, which is 1 plus tangent squared theta is equal to secant squared theta. So this is our second Pythagorean identity. Again, the numero uno, the number one identity of all time, is cosine squared theta plus sine squared theta equals 1. But from that one, we can divide by cosine squared theta and get our second Pythagorean identity. Okay, so you might be thinking, well, Diane, that's all great and all, but why did you pick to divide by cosine squared theta? What's so cool about cosine? Well, the answer is it's not that cool. It turns out that there is a third Pythagorean identity where we will take cosine squared theta plus sine squared theta equals 1. That's our number one trig identity ever. And instead of dividing by cosine squared, we're going to divide by sine squared theta. And your job in part of your remote assignment is going to be to do a similar process that we've done here. Instead of dividing by cosine squared theta everywhere, you're going to divide by sine squared theta. Now, your job is going to be to show the intermediate steps here until you get to the very end. And what should come out in the wash after you work through remote assignment number 2 is the last Pythagorean identity, which is cotangent squared theta plus 1 is equal to cosecant squared theta. Okay. So all of the work that goes into that is part of your remote assignment after you watch this lecture. All right. So what we've talked about in this portion of the lecture is the 3 Pythagorean identities. That wraps up all of the fundamental identities, all of the identities that are listed on this board, the quotient, the reciprocal, the even, and the odd, as well as the 3 Pythagorean identities, are fundamental identities that you want to know like the back of your hand. So I would recommend making a list of them, maybe posting it on your refrigerator, maybe writing it on your bathroom mirror, whatever you do so that you can memorize these identities. Okay, thanks for listening.